with this choppiness? Okay, well, settings. Uh, I. Hmm. Okay, maybe it's just my down. Okay, so maybe my downlink is working. Okay, well, my preview is not working. Okay, we're gonna go in blind, I guess. On Servos. Save. Okay. Yes, not going to worry about the live preview. Okay. So as long as the video's moving and everything's happy, we can move forward. Okay. We're gonna try this again. So today we're gonna go try to look at Servo for the hack pack in an RD FPGA. And I'm gonna have to turn off other systems. Okay, so let me focus on the chat here. Chat box isn't working. Oh, it's so weird. I'm not getting any chat messages. Okay, I need to open up the chat boxes at least so I can actually watch. There. Okay, ignore me for a few seconds while I set up. Oh, what's going on? My receive side of internet is working very well. Okay. Okay. Um, video and sound. Check. Okay. I can see the chat message there. Okay, seems pretty fast. Hopefully this works out well. Okay. Whew. I have my chat boxes over here. Let me try to pop them out. Pop out the chat. Pop out the chat. Cool. I'm going to ignore my video output and just look at the chat boxes. Hopefully I get better at checking these more often. There we go. That. You. Okay. Welcome to this video. We changed the YouTube link because I thought YouTube was acting weird and I was trying out again. We're doing low latency, so hopefully you guys have better back and forth between chat and me. And hopefully you see the screen in good detail, that the resolution is correct, and you can read and follow through the code and whatnot. If you have issues, we can try to increase the font and whether application we're in. Okay, so last Sunday, we were able to get the IR filter or the IR input working and the roll motor working, servo working. Today we're going to do some more HDL servo control, and we're going to look at using ChatGPT for development. But let's go do a quick review of let's go do a quick review of the controller IR system. So if you follow the example last week, we were going through and doing doing the IR input from the controller, where we have address. So we have address right here, and then we have data later, and that's where we get our information for our controller. So now we're going to look at doing HDL development for the servo. And so let's go ahead and go to IP integrator. Go ahead and open block diagram, and then we're going to look at using ChatGPT to do servo controls. Just cleaning up something to try the videos again. Login. Okay, try. This one. Okay, Twitch. That go. Okay. Everything happier. Format. Okay. Seems like we got pretty good low latency, and we can chat with everyone. Okay. Let's go actual to the fun now that we have everything set up appropriate. So we want to play with the servo sensor here. That's just a single line. So let's go ahead and work on the servo control. So servo control uses pulse width modulation over a 20 millisecond period. You provide a specific width of the pulse, and it will do a fixed change. If it's a fixed servo, it will go to the same position every time, I believe. And if it's a continuous servo, it will do a difference based upon the current position. So let's go ahead and latency latency see seems low. Have to play with the latency settings. Get a chance. And maybe we'll just do what we okay. Go to the so we're gonna use ChatGPT to do this. And we're going to do a simple code instruction of like, can you write some VHDL code to control servos? And here is our example. So we have an angle of 180 degrees. Let's say we're gonna say assume a 100 megahertz system clock and a continuous servo. Continuous servo. So continuous servo control. We have our 20 milliseconds, and we have our pulse width, and we're going to do b times 1,000 divided by 50. Let's ask it if multiplication is the best for HDL. So, okay, let's see. Here, what does it do with the so speed times okay. Let's look through what we got so far. We have a clock, we have a reset signal, high reset, we have the speed, the pulse width modulation out. We are assuming 50 hertz, 28 millisecond period of 100 megahertz clock. Have our counter, and we're going to have our speed times. Okay, let's try. Can you use a shift instead of multiplication? Okay, so calculate the pulse width. Instead of using multiplication, we use shift. Speed can be written as speed times 1,024 divided by 1,020. That seems weird, right? But they're doing 2 to the 10th. See what that is. 1,020. I don't know how you're. That doesn't make sense. Ooh, I don't like that one. I had the calculator up. I just like Google better sometimes. Because you have to go to the scientific to get. Okay, so I don't like that one. What's the multiplication? Look right here. Ooh, maybe we'll just take this one. I don't believe this. Okay, I like that. How did they? Their position. Um, position. Are they using their position? Position plus 32. I like that better. Speed. I feel like you could do times 16. Okay. I really like the what did they do in this earlier? It just does the multiplication. Okay. Oh, thank you. Thank you for the comments. Hidobu, thank you. Let's we can do by 4 to get this. Um, it's wide. It has. Okay, so let's go ahead and bring this to um add a source, do a create a file. We're gonna do VHDL. Yeah, well, this is continuous servo, and I'm not sure. Let's see. How does a continuous servo see? Okay, when the pulse width is around 1.5, the servo stops rotating. That's neutral spot. Forward rotation causes the servo to rotate, and one further the pulse, the faster the servo rotates. I assume this is just an angle. We can play around with it. Full reverse, neutral, full forward. So this is the example they show. All that. HD. Um, okay. Let us see the code. Save it. Ooh, it's formatting. Pulse width. Sure. Speeds. Sure. Ooh, you don't like that math. Okay. Let us make this the status top, and we're going to run synthesis and feed the error message to ChatGPT. See what happens. Are you? It's not. It's actually an integer. If you look, pulse width is an integer. And current type integer, expected type big vector. I am curious. Yeah, view messages. Copy message, right? There for uh, back to the bad thing. Okay, let's try this. Can you write a VHDL servo controller with continuous servo controller with standard logic vectors fed. Try this again. Like that. Okay. You can have them multiply. I don't really care at this moment. You happy? Will you run synthesis? Curious how it's doing the multiplication. Go see what it does. Oh, it still used integers. Oh, it's interesting. Hey, welcome. We're exploring ChatGPT for servo controls. Okay. Okay, completed. Open up the netlist. See what it did. Okay, while we're doing this, let's go back here. Hey, John. Write a test bench for this, please. Back here. That's fine. We're looking. Let's follow the follow feed, but right. I'm sure. Go to the bottom. Pulse width. We're doing DSP functions for it. Wow. Um. So we're gonna use a DSP for this. That's okay. So let's try the test bench out. Going to go simulations file, add a new course, create file, FPGA. What we're gonna call this? P server controller .vc. Okay, identified it. Perfect. Top file, simulation, settings. There's the simulation. I think let us not. Okay. Let us run a simulation. Hopefully running it for 20 milliseconds. Okay, what errors did we have? Okay, we're saying continuous line control, pulse width. Where is it driven? Ah, can't do that. Okay, let's tell it. Let's tell ChatGPT this. Ah, someone effectively use. I want to type and correct it. We're going to let ChatGPT correct it for everything. I don't. Okay, you did it all in one process. Let's see. You fixed it. Relation. Okay. Run 20 milliseconds. Zoom out. Okay. This was supposed to be that's 0.2 milliseconds for a speed of 80. Let's run it 80 more milliseconds. Okay. Speed of 0 should be 1.5 milliseconds. Okay. That correct according to our little graph up here. Okay, 1.5 is neutral. So there's our neutral. There's our pull forward. Okay, let's see. Can you add print outs in the test? Pilot. Copy code. Save. Recompile. And run for 200 milliseconds. Okay, let's see. What are we supposed to be seeing here, right? Test bench. Yeah, the out. This line doesn't make sense at all. Okay. Um yeah. So I am happy with that waveform. So I think we're good. Wait a minute. Oh, there we go. So test bench work. Now we're going to up the game a little bit. We're going to make it a little bit harder. We're going to. Can you add FIFOs to stack multiple command? Favorable wait command for the continuous servo control. Okay, where FIFO? Did it integrate the FIFO? New generating. Let's finish. Ask it. FIFO is a separate file. Can you do the FIFO as a go ahead and copy Mr. FIFO. Download it. Okay, back here, we're gonna do a new source file. Probably bad to just FIFO, but okay. basic. Like about not read from object full. Provide an internal signal for the FIFO module. Provide an internal signal full and empty internal that should be okay. Thanks. You don't have to go. Write everything, every cycle. Sure. Okay. Let's um FIFO 4 for the module and you wait part of the feed. Okay, see you, John. The wait part of the speed command, so it's stored the FIFO. Does it ever say wait? We'll fix that one. Oh, Turning out everything. Just resolve the uh, node definitions are and this is going slower than I expected, but I wonder how hard you have to work to get this going. Was that going to actually work? Did it there? Are you going to be happy? Trying to compile it. Let's help it. And to assign to a temporary value, temporary that logic a put for the all your there we go. Code. It should be happy. It should have done it by itself. Okay. And you provide a test bench for this module that fills up the FIFO. Checks that and runs correctly. Oh, we should ask it to do random commands. Ooh, I'm happy for that. Ooh, it wrote. Ooh, it did fancy stuff. Okay. Are you going to be happy? Are happy. Okay. Let's go back to simulation. Ooh, bring it in properly. So we do run 100 milliseconds. are all I say start. Not changing anything. Wait for clock period 10. This is supposed to be happening at the beginning when that okay, let's just run simulation. So add printouts by verification. Of the for change. Anything change? Grand valid did go high in the very beginning. Go all high. Okay. So it did do it. Let's do a virtual bus. Create virtual bus. So it did do those. FIFO not working. Add to wave window. So starts grid. Okay. FIFO data out. Okay, the module did not wait. Okay. Qt wait for being birds. Array 0 to 4. What else? Oh, it lost the syntax battle. We might have to ask for a new. Say here. Where does it the reading of FIFO? FIFO. Okay, let's try this. Run. Waiting. So waiting. Waiting. Waiting goes down. Wait counter. FIFO empty. Waiting. Signal day high after 20 milliseconds of the modulation period. Okay, so I think we've learned that it's having and PMW. Where you okay. I was really wanting to get the Axie interface. Okay, back to the waveform. 40. Oh, it worked. Waiting command. I don't think really. It's run 100 seconds. Okay, let's try again. Say, to provide HD and a info packing. Okay, restart. You happy with that one? You're happy with that one? Try this one. You're happy with that one. Okay. And you provide a test bench. We can Hertz Club. Okay. Um, okay. Fully fill the oh, an issue. Set up use the FIFO for or execute tell and execute tell execute them or also station command. Okay. Um, let's try that. Let us card. Yeah, I do agree. And it's like you want to go back. If ChatGPT gives you like corrupted answer and you want to go back and try something different, you gotta like do a new instance and start from scratch. Kind of interesting. Run this for 200 is FIFO opposite. Really confused. Okay. It's That's what, right? Put all the commands in. Read command. Yeah, it emptied the FIFO. We're having an issue again where it's not waiting to do the data. Where's the read signal? Where's read? Oh, it's controlling the write. Read. Oh, you have to. That's a nice way to prime something and run it. Okay. Try one more time. Tell it. Or there should be 20 milliseconds to FIFO. Oh, we could ask it to do that. Um, it just sets up a whole new read into. Um, so the read counter or the poll. Okay. And you main uh that's bad. Okay. I want to get to the axis part. Hopefully this works because next time it will. ChatGPT. Go ahead. That doesn't look right. Ah, looks wrong. Looks terrible. Okay. Um, we're gonna go on to Axie. I want to try something. So if we go to HDL, ports directional. Okay. Axie gram temp. Place macros. Should be there. Okay, we go over here, right? Open diagram. Guy, right? We have LBM. Let's see. LBM? That where is it? They move it? Must have moved. That doesn't make sense. Okay, see if I can find where the design links are. Where are photo links? Do I need to like look in the code for them? The good question. What are we looking for? Tries LBM RTL. LBM. Be able to that see R LBM RTL. Go. Where are these interfaces? They have these interfaces. You can use them for different things, and they used to be able in the language template. Let me open up the other Vivado, and I'll show you. Got rid of it. That is the weirdest thing. The in hubs. Um, so we go to language temp. Type in there. Right here. Integration interface. Advanced interfaces. Okay, that IP integrator HDL. Okay, let's open up the other tool. Clear. We have the HDL IP integrator. Okay, here we go. Really hard to find. Okay, I want Axie light. Which interface? Okay. What are we doing for this? Actually, MMRTL. The MML. Basic. Okay, so let's try this. Try this. Okay, can you add a axis for light interface using this naming convention? Okay, I want to see if this. Let's copy this. Wanting to do a test bench? Is that what you want to do? Period. We all do. Okay, so I'm gonna try this. Happy. Okay. Now if we add this to the diagram, it pop in. Add module and say this guy. Look at that. It has an axi bus. So if that axi bus works correctly, it's now properly named. Okay, so we just need something to work properly. Okay. Let's try again from scratch. I want to do a whole new one. Right? Can you implement a HDL servo controller? Servo controller and axi for light interface using this temp. Okay. Not that. Which templates? There we go. Copy. No FIFO, no nothing. Just use this template. Yeah. Yes, perfect. Oh, I had to change the link. I had to fix. Okay. I keep generating. How long? Okay. Let's diagram. Let's just go add a new servo folder. D. Okay. Are you happy? Plop this down in the diagram. XE4 light. Okay, works. Let's write a test bench for this, and then maybe we can try running it. This will become a long string. And you So is duty cycle based upon based upon okay, we're gonna first, first we're gonna do what? Servo D. Wait properly. And okay, we'll set it as top and we'll run it. I don't think this is going to work again. At least the control side. Go to yeah, signal. Okay. Um. Okay. For the module servo control output kernel value if you can. Now you know. Oh, write one from scratch for before we get back. I like what it's doing, but it's first off the token size is this simulation. They're running this. Oh yeah, we're not doing continuous. Monose, we're not going to do continuous for this. We're going to just keep it basic and just see what happens if we do run 20. Servo. Yeah, I guess it gets tied to 0 because 42. Okay. Um, for the tool, B, add 40 second waits. Right. Should ask to do system verilog. There's probably way better system verilog. We should do that next time. We should ask for system verilog. Okay, cool. So this should operate as I okay, regen. Back here, I want to let's add the duty cycle. Run dash a zoom out. Yeah, didn't work. Uh, why did you work? You writing that data, write data, write data, write the FA5. Do I see that the waveform? Write data. That's not changing. Oh, maybe it's waiting for a response and not responding here. So we're waiting. What are we waiting for? So we set this value, looking for W ready to go high. W. I do. Seconds. Where are we? Okay. W red goes high. And we're waiting for B valid to go valid. Did it ever go low? So what's driving B valid? Valid is here. Servo control. Where is valid? Okay, B valid. Kernel 1. Kernel 1 goes high. And we have AW valid and AW ready. Okay. Um, so do those not all go high at the same time? So we're looking for AW valid. Okay. So back here, W valid, AW valid. So W valid, AW. They're not high at the same time. Okay. Last time I'm doing the last ChatGPT thing. Or the AW valid, B high time for A. Correct. Oh, okay. Stay here. You are right. Thank you for telling me. Why they're doing. Okay. Let's try this. Code. Save. Here. Okay, let's now run. Gonna work fast. It's still waiting for things. It's still waiting for the B valid to go high. Uh, Both go high, both go high, but be valid never goes high because it's only a cycle. Okay. We give up on doing axis simulation. Oh, that was annoying. Okay. Next week, we're gonna skip the ChatGPT and some real fun. And not do this frustration. I'll probably auto write something or I'll write something ahead of time to make this go by faster. But that's it. Um ChatGPT failed. Uh uh and the issue is just the protocols and the things you don't know. You don't you it it'd be quicker to write it from scratch than trying to fix ChatGPT. Impressive that it gets close enough. But that 5% that it's failing is really annoying. If we can fix that 5%, it'd be great. But we're not fixing that 5%. And it's going to uh aggravate me so much. Okay, thank you for joining me on this. I'm sorry I had to set up the stream again. I'm gonna try to do some options later. Um, well, try to set up something for later this week, maybe tomorrow. Keep notifications for YouTube. I might post a schedule to Twitter too, or Twitch and Twitter. I might post schedules. Okay, thanks. Good night. Um, okay, I think that's